when we start with trigonometry, we always need to start with this dude. Okay. How many of you guys, tell me with a yes or no in the chat, how many of you guys have heard of this dude named Pythagoras? Pythagoras of Samos. Oh, I'm seeing a lot of yes. Most of us have. Yeah, we've heard of Pythagoras, right? As you can see, I was joking in the other class with teacher Nels that like, I feel like this dude was sitting with his curling iron and his beard and just, hey, having the time of his life because his beard game is on fleek. I'm just like, yes, yes, yes. Like the 476 AD was lit. I know Zanuguche the picture, hey? It's a lot. Oh, Michael, I'm so glad. Dude, it's literally only been 4 days. Okay, so Pythagoras of Samos is actually, he was actually a philosopher and a mathematician as well. And the people who were following him were called the Pythagoreans. Okay, so he had a group of followers and they were called Pythagoreans. Okay, it wasn't uncommon for philosophers to have people who studied their work. It was something that was quite common around that time. Okay, so the people who followed him were Pythagoreans and they believed in the beauty of numbers. So the numbers 1 to 10, they believed in how that each of them had like a very specific meaning, like 1 symbolized unity and 3 was very important because it symbolized the beginning, the middle of, and the end of something. 4 represented the 4 seasons that we have in a year. So there was quite a lot that the Pythagoreans actually came up with around the idea of numbers. And what they did was they took these numbers and they figured out that the numbers themselves actually have a lot to do with right-angled triangles and how right-angled triangles fit into everything that was happening at the time. And we realized like, oh boy, that was sad. I mean, they didn't have Instagram, they didn't have TikTok, they didn't have Facebook. What else could they do except, you know, but he was the main influencer, guys. Imagine having people following you in real time. Like these days we follow people on the, you know, on the interwebs. He had people following him for real. Okay. So sure, Mputu, we've already done simultaneous equations actually. It was a tough life without internet, you know what I mean? So he was the ultimate influencer back then. All right, and him and his people figured out that if we have any shape, literally there could be a man sitting over here. This could have been a building like this. Okay, building with the little windows. Okay, with the little windows and blah, blah, blah. They realized that if they could measure from where this little dude is standing all the way to the top over there, this would give them a right-angled triangle, a 90-degree angle over here. And they realized that if they took the distance from here to there and they squared it, and then they took the distance from the bottom to the top of the building and they squared that, that would give them this side, the length of this place over here, squared. Okay. Mbali says, when is the quiz? Quizzes are on Wednesday. Okay. Hi, Mulisa. What's up, my sweetie? I see your hand is up.
Yes. Hi, ma'am. Okay, I know the hypotenuse, ne? But
yes.
ain't we supposed to have adjacent and it's hypotenuse, adjacent, and what is this?
The opposite. Yes.
Yeah,
absolutely.
Opposite.
Now, the reason why this says the base and the altitude is because this was the original way that they found it out. Because they were looking at the distance from where they were standing to where the building was. That's why they were using the base. So that was the ground versus the altitude, which was how far something was from the ground. So you are correct. We don't actually call it, these days, we don't call it the base and the altitude. We call this side here at the bottom the adjacent side. So this would be adjacent squared, and this side would be our opposite side squared, and this would be our hypotenuse squared. Okay, so you're not wrong, not at all. It's just that Pythagoras exists in most things around us. Okay, that's the reason why the building you're sitting in right now, that's the reason why the building doesn't tilt and fall over, because of the idea of Pythagoras. Okay, So we're going to do a little bit of Pythagorizing ourselves. Okay. We're going to do a bit of Pythagorizing ourselves. We've got questions 1 to 6 here on Pythagoras, and I'm going to give you guys a quick refresher on how to do these. All right, we're going to look at number 1. Now, remember, Pythagoras says the short side squared plus the short side squared equals the longest side squared. So if I write this down, I'm going to write 9 squared plus 12 squared is equal to x squared. Or I could even write it the other way around. I could say my longest side, I could do that. I prefer this way actually. X squared is equal to my 2 short side squared plus my other short side squared. And I have to give a reason for this. I'm going to open brackets and I'm going to go Pythag. Because where did this formula that I'm using come from? It came from the Pythagorean theorem. Then I can go x squared is equal to 9 squared is the same as 81. And 12 squared is 144, right? Then I can go x squared is equal to 81 plus 144 is 225. Now, I don't want x squared. I want x. So I'm going to square root this side and square root this side. Yes, Melissa?
I wanted to say the same thing, ma'am. I wanted to answer it.
That we square both sides. So what is my answer going to be? Therefore, x is going to equal to? Square root of 225 is? 15. Good, 15. Why did we not take, Melissa, let me ask you this question. Why did I not say plus or minus? Because normally when we do this, when we take the square root of something, we normally say plus or minus. Why didn't I say plus or minus 15? What do you think?
Okay. I'm not sure how to explain it because my set didn't tell me. Ma'am, I'm not sure though, but I think because we square rooting, I guess.
Of course we're square rooting, so we should have gotten plus minus 15, but I didn't say plus minus 15. I only took the positive 15. Okay.
Yes.
All right, and the reason for that is if I am measuring something, let's say I'm measuring this line, Melissa, can
Yes.
my line ever be negative 3 centimeters long?
No.
No, because distance is always, can it ever be negative?
No, it can't be.
It's always positive. That's why we don't need the positive or the negative. Okay, that's why we only take the positive. It's because we're measuring the distance, and distance is always positive. That's why we only take the positive answer. Okay, I hope that makes sense. Okay, yes, Jasmine.
If in maths you cannot have a negative number to measure distance, right? Like your
Yes.
line example. Why, if physics and maths is linked, then why in certain things for physics they got to the 10 to the negative of a number?
Okay, okay. So are you talking like things like 10 to the negative 5, like that?
Or 10 to the negative of 9.
Oh, 10 to the negative of 9. That's just, it gives us an idea of a scale. Okay, Jasmine. So basically what's happening, okay, just give me 1 second, guys. This is the answer to number 1. I need everybody to try number 2, 3, 4, 5, and 6 while I explain this to Jasmine quickly. Okay, so Jasmine, when we normally look at distance, we are going to take our reference as 1. Let's say, for instance, maybe 1 centimeter. Okay, if we're looking at 1 centimeter, anything smaller than 1 centimeter is going to give us a 0, something. Okay, like maybe a 0,1. This will be millimeters. Okay, now the smaller I get, the more zeros they're going to be. Like, let's say I want to go to micrometers. Micrometers. This means there's 0, 1, 2, 3, 4, 5, 6. Okay, I have to then look at, instead of having to write all of these zeros, what is the easiest way of me to write this number? And that's where the negative exponent comes in. I can just count how many times I've moved the comma, and I can use that to express the very small measurement of what I have. Do you understand what I mean?
Yes.
Okay. So my answer isn't going to be -1 times 10 to the power of -6. No, my answer will still be positive. This part over here will still be positive. It's just that this will tell me how many times I have to move my comma in order to make my distance smaller and smaller and smaller. Okay, I hope that makes sense.
Thank you.
You're very welcome, my sweetie. Mirula says, ma'am, we want to solve 4. Yes, solve number 4. Go for it. Solve 4, 5, and 6 as well. Okay, yes, Kioratile.
Hello, ma'am.
Hello, my sweetie. What's up?
Ma'am, I just wanted to ask if I could please answer number 2. I'm not sure,
Okay.
but yeah.
No, absolutely. Yes, you can. So keep your hand up. We're going to talk about number 2 in just a bit. Okay.
Okay, ma'am.
Good. Ashimile says, wait, are we doing Pythagoras? Yes. Yes, we are. Yes, we are. Mirula, if we want to answer number 4, we're going to have to put our hand up. Okay. Because there are quite a lot of these, and I'd like us to do them all together because we're balling over here. And I have a feeling Mirula has the answer for number 4 for me. Okay. For those of you who are like, ma'am, can I answer this? Can I answer that? I'm going to need you guys to raise your hands because there are quite a lot of you who want to answer the questions. And if I don't choose you to answer the question, guys, it's perfectly fine. I have many more questions coming up, and you can always raise your hands for those and you will get a chance to answer. Okay. Kioratile, would you like to help us with number 2? Let's do number 2 together.
Yes, ma'am.
What am I going to write?
So, ma'am, when I started, I said 10 squared plus 24 squared is equals to x squared. And the reason is Pythagoras.
Beautiful, beautiful, Pythag. Yes.
And
Okay.
then ma'am, 10 squared gave me 100, and then plus 24 squared gave me 576.
Beautiful is equal to
X squared.
good. Okay.
The 100 plus 576 gave me 676.
Is equal
Is
to x
equal
squared.
to
Good,
x
but I don't want
squared.
x squared, I want x. So what do we need
And
to
then
do?
I square rooted the 676 and the x squared.
That's it. Therefore,
X is equal to 26.
oh, beautiful, amazing, amazing. Okay,
Thank you, ma'am.
you did that. Mwah. Excellent day. Amazing. Very well done. Michael, can we try number 3? Hi, Michael. Kioratile, I'm going to need you to mute for me, my sweetie. Hello, Michael.
Ma'am,
Yes.
sorry, ma'am, I just got caught. The internet cutted me out, ma'am. So I'm only catching up now, ma'am.
Okay,
Also,
that's okay.
ask-
Watch how we do this next example, and then I think you'll catch on. It's quite easy. Okay. Okay. All right. Amy says, do we lose marks if we don't add plus minus? No, we don't, Amy, because we're measuring for distance and you can never get a negative distance. Okay. If it was another sum, if it was just like a normal algebraic sum, yes. But because we're measuring for the length of things can never be negative. So no, you won't lose any marks. Okay. Mobile, do you want to do number 3 with me? Excuse me, guys. Mobile, are you there?
Hi, ma'am.
Hello, my sweetie. Let's do number 3 together. Are you ready?
I wasn't planning to do number 3. I wanted to ask something about number 2.
Yes.
Why did you decide to start with 10 squared plus 24 squared equals x squared instead of starting with x squared and doing the 10 squared plus on the other side?
It's fine because here, you see how Kioratile just did it for us? You can do it in this order. It's perfectly fine. Okay. Even if you switched it around, the answer would be the same.
Okay,
Okay.
that's the only thing I want to know. Thank you.
All right. Ketiwe, do you want to answer this next one for me? It's not that difficult, guys. Come on. Hi, Ketiwe.
Afternoon, ma'am.
Afternoon.
No, I don't have an answer for this one, unfortunately. But I would
Okay.
like to say that for trigonometry, aren't we supposed to be using the trig ratios to solve the triangle?
We're going to get there, but the trig ratios stem from what we're doing now.
Oh, okay. I see. Thank you,
Okay,
ma'am.
so we need to start here before we can get there. Okay.
Okay. Okay. I see. Thank you.
All right. Okay. All right. So I'm gonna do number 2 because it doesn't number 3 because it doesn't seem like anybody's done it. All right. So I'm gonna get 7 squared plus 3 squared is equal to x squared. 7 squared is 49 plus 9, 3 squared is 9, which is equal to x squared. Ooh, I forgot Pythag. Pythag. 49 plus 9 will give me 58 is equal to x squared. And then I'm going to take the square root of both sides. It doesn't have to be the negative square root, or the positive and negative, because we're measuring a length. Therefore, x is equal to the square root of 58. All right. Now, I know that this one isn't a perfect square. It's not going to give you a nice answer. Do not give me the 7 comma whatever it is. Leave it as a square root, exactly the way it is. Do not write 7,61. Okay. Leave it as the square root of 58, because the second you say 7,61, what happens is you cut off the rest of the answer. Okay, we do not round off at all. You leave it. Yes, that's it, David. You leave it in third form. You leave your answer underneath the square root. Okay. Bikuko, I understand. Don't write it that way. Leave it as the square root of 58. Don't change it. Okay. Leave it exactly the way that we see it here. All right. Okay, let's look at number 4. Mirula, are you ready? Let's do number 4.
Yeah, I'm ready. Okay. Can you
All
hear
right,
me?
let's go. Yes, I hear you fine. Let's go.
Okay. 10 square equals to 6 square
10
plus
squared.
x square.
Is equal to
6 square plus x square.
beautiful. My reason.
Because hypotenuse is 10.
I need
Wait.
this reason. Understand why you're doing that.
No, okay.
That's what I need. Okay, all right, continue.
100 equal to 36 plus x square.
That's it. 36 plus x squared.
64 equals to x square.
Beautiful. For those of who don't understand what you've done, we've taken 36 over to the other side is equal to x squared. Therefore,
X equals 8. 8 x.
X is equal to 8. I knew you were going to get this one right. 100%.
It's my favorite. It's my only favorite job.
Is it?
Yeah.
I'm glad because you're doing this so perfectly. I don't even have issues with you, dude. I knew you were going to get it. Excellent stuff. All right, let's look at number 5 quickly. All right. For those of you who are like, what in the world just happened? Remember, the short side squared plus the short side squared equals the long side squared. So x squared plus 6 squared equals 10 squared. And that's the reason why Mirula is doing it in the order that he's done it. Okay. So we need to make sure that we are understanding why he's doing it. Mulisa, would you like to do number 5 with me?
Yes, ma'am.
All right, let's go.
Okay, you wanna say x squared equals to 24 squared plus 6 squared.
Oh no, Melissa, you fell for the trick. Remember, short side.
Oh yeah. Oh, sorry.
So we need to go x squared plus.
Oh, plus is it 24?
The short side.
6
X
squared
squared plus 6 squared is equal to
24. 24 squared.
24. That's it. And my reason is Pythag. Yes, you're with. Okay, good. So now over here, I'm going to have x squared plus what is 6 squared, Melissa?
6 squared is 36.
Good, it's 36 which is equal to 24 squared is
576.
576. Good. Now I want x on its own, so I'm going to take 36 over to the other side and it's going to become negative. Do you agree?
Yes.
Okay, so I'm going to get x squared is equal to 576. Finish this for me.
Do we minus
Yes, because it was positive
Minus-
this side. Minus.
36?
Good, minus 36. All right, so x squared is then equal to 576 minus 36 will give us
540.
good 540. And then we're going to take the square root of both sides. Right now, I'm not going to get a perfect answer for 540. So what
Yes.
am I going to do? I'm just going to leave it in my square root. Okay, so therefore x is equal to the square root of
540. It's not giving me a perfect answer, but it says 6 square root of 15.
yeah, good. So we don't want to say 6 square root of 15. We're just going to leave it as the square root of 514. Actually, teacher won't have a problem. Even if you wrote x is equal to 6 square root of 15, no issues. You would still get your marks. Okay,
Yes, ma'am.
excellent. All right, well done. That was beautifully done. Akwimile, do you have a question for me, my sweetie?
On my phone, I should take pictures of this. On the phone.
Melissa, you need to mute for me, please, my sweetie.
Oh, sorry.
Hi,
ma'am.
Akwimile. Yes.
Hi, ma'am. I see that you
Hello.
when you do like your pythag, you say x squared. So what I know is like you can like say ab squared, something like that, like labeling your triangle. And for number 6, what's number 6? No,
Mm.
it wasn't number 6. I think it was the can you please like go to the side, ma'am? I want to see like the question number.
Which one?
Yeah, for question number 4, ma'am. So like what
Yes.
I know is you see when it's not like a hypotenuse, so you like minus the thingies. Yeah.
Okay, Akwimile, we're not actually minusing. Okay, remember, when we find the square side, we always take the two short sides squared and we add them to get the long side. So do you see how this is a short side squared plus a short side squared will give us the long side squared. So that's actually what we did. And the reason we're minusing is because x squared is a short side.
Yes, ma'am. Thank you.
Okay, you seeing why we have to move things around?
Yes, ma'am.
Okay, excellent. Good. Kyoratile, I see you say you also have a question. Okay.
Can I ask a question?
Yes.
At number 5,
Yes.
would it be wrong if I jump straight to 24 squared minus 6 squared?
No, not at all.
Okay, thank you.
Not at all. Okay, because you understand the maths that's going into that, so it's 100% correct. All right. Okay, and this is Pythag. Okay, I'm doing this one because this one is actually the easiest of them all. X squared is equal to 1 plus 1, which is just 2. Therefore, x is equal to the square root of 2. All right, give me in the chat a number out of 6. How much did you get? 5 out of 6, 6 out of 6, 1 out of 6. How much did we get? David got 6. I love it. Kiratile also got 6. Awesome, awesome, awesome. All right, everybody's getting 6. I'm loving it. I'm loving it. Because I knew that you guys could do it. All right. Oh, let me see. That's okay, Tankolo. It takes practice. It really does take practice. Okay, let's do this properly. Tan of theta is equal to opposite over adjacent. Okay, now, just like I think it was Kitty who was asking, I was asking, ma'am, isn't trigonometry about those sine, cos, and tan people? Yes, it is. Okay. So this is where we're actually going to start. Okay. Now, Pythagoras himself and the Pythagoreans, okay, they didn't actually come up with the idea of trigonometry. The person who did was this dude, Hipparchus of Nicaea. Okay, and he figured out that, hold on, okay, if I have a right-angled triangle, and I can create this right-angled triangle out of anything really, right? Let's say I take a stick, and this stick, I'm going to use the stick as my hypotenuse like this, right? He realized that if I put the stick at a particular angle over here, now this sign over here is the Greek symbol theta. Okay, I know if you're in America, they're going to call it theta. We don't call it theta, we call it theta. Okay, theta stands in the place of our angle. Okay, so if I choose my angle to be 30, then I can say that theta is equal to 30 degrees. Okay, at the moment, I'm just going to call it theta, okay, because we're not quite sure what it is yet. Now, what Hipparchus figured out is if I choose some angle for this stick that I've put up, this angle gives us a certain length for the side adjacent to my angle and gives us a certain length for the opposite of my angle. And then he was like, okay, hold on. Now, what happens if I keep the length of my stick, but I move it a little bit down? So I make my angle theta a little bit smaller. He realized that if I make my angle a little bit smaller, my opposite side gets smaller and my adjacent sides get bigger. My adjacent side gets bigger. And he's like, hold on. If I make this angle even smaller, my opposite sides get even smaller and my adjacent side gets even bigger. All right. And the idea behind this sine, cos, and tan is that however much we make the angle theta, that is affecting the opposite side and the adjacent side in relation to my hypotenuse. So whatever my hypotenuse is doing to my angle, that will determine whether my adjacent would get longer or shorter, and it will determine whether my opposite side is getting longer or shorter. Okay, so these sine literally tells us what is happening to our opposite side in relation to our hypotenuse. The word cos is going to tell us what is happening to my adjacent side in relation to my hypotenuse. And my tan is going to tell me what's happening to my opposite side in relation to my adjacent side. Okay, can I get a thumbs up? Do we understand what is happening with our angle in relation to our opposite, our adjacent, and our hypotenuse? Ubuntu says yes, 100%. I got you, ma'am. Somebody is a little bit confused. Pesitla is confused, and I'm going to explain Tandu Polo. Don't worry. We're going to get there. Don't stress. It's not that deep. I promise. It's not. Somebody just said exuberant. I love that. Who is that? That's Samuel. Love it. Yes, Amber, you're 100% correct. Okay. There is a word that's going to help us remember all of these. The mnemonic device. Oh, look at what I did. Ooh, Teacher Coco, what are you doing? Okay. The mnemonic device that helps us remember this is so, ka, to. Okay. No worries, Yola. So, ka, to. And before we continue, I'm going to take Ngobile's question. Okay. Hi, Ngobile. Ngobile, you need to unmute for me, my sweetie. Hi.
I don't know what's going on. I wasn't meaning to ask a question.
You were?
Probably it's a mistake. I wasn't asking.
Oh, okay. That's okay, my sweetie. All right. Okay. I'm going to explain now just so we're not lost. Okay. Now, I'm going to write down an angle theta. Remember, theta just stands for some angle. We don't know what that angle is, right? There's always a right-angled triangle, just like Pythagoras taught us. Pythagoras taught us that there's always a right angle somewhere, right? Alusha, don't stress. We're going to learn about these. Now, I'm going to name my triangle A, B, and C. Okay. Now, when we refer to the sides of these angles, yes, that's it, Ketiwe, a reference angle. Good. When I refer to this side, I'm going to call this side side AC because it goes from A to C. So I'm going to call it AC. And then this other side over here, I'm going to call it AB because it goes from A to B. And my last side, I'm going to call BC because it goes from B to C. Okay, that's pretty easy. I have no idea. What did I just do? Okay, there we go. Hey, I did something funky there. I don't know what. All right, so when I look at my angle theta, this side AC over here, that is right next door to my angle, this one over here is called my adjacent side. My adjacent side. Okay, it's called my adjacent. So every time we think about the angle, the side right next to it is called the adjacent side. Right. Now remember from Pythagoras that the longest side is always called the hypotenuse. Okay. The longest side is always called the hypotenuse. And the side, that's it. Beautiful. Kyoratili is going to teach this lesson for me today. I mean, just going to teach it. Right. And the side that is always furthest away, this is called my opposite side. Okay. This is my opposite side. All right. Yeah, mathematician of note. I feel it. All right. So depending on where my things are sitting, these sides are always going to affect what's happening. Now, if I do this, if I ask you guys, I deleted my B. Okay. What is the name of my adjacent side? What is the name of my adjacent side? What would I call my adjacent side? Put it in the chat, guys. Tell me. That's Samuel. That's it. My adjacent side is AC. My adjacent side is AC. Okay. What is the name of my opposite side? What is the name of my opposite side? That's it, Zamanzini. Beautiful. That's it, Nompumelelo. Yes. Joash, Ahmile, you guys are spot on. It's BC. Right. And then, what is the name of my hypotenuse side? What is the name of my hypotenuse side? You guys, I have a feeling some of you guys have already had AB typed in. And then as soon as I said, what is the name of hypotenuse? Enter. I didn't even finish my sentence. Good. My hypotenuse side is called AB. All right. This makes sense. Yep. This is easy enough. We're looking at it that way. Let's complicate life a little bit. All right. Let's complicate life a little bit. I'm going to move theta. I'm going to move theta over here. There it is now. Which means this stuff isn't going to be the same. Melissa, don't put your hand down. Come back. Hi, Melissa.
Hi, ma'am.
Hi. I need you to tell me, Melissa, which side is my adjacent side now? What is the name of my adjacent side?
Isn't it AB? No, I mean BC.
BC, good. The one right next door. This one. This is my adjacent side. Good. So my adjacent side is BC.
BC.
What about my opposite side?
AC.
Good. It's the one far, far away. This is my opposite side. So this one is my side AC. Good. And my hypotenuse?
AB. I mean,
good.
Yeah, AB.
My hypotenuse is always opposite my right angle. So this is AB. Beautiful. Melissa, you're always a rock star. Love, love, love it. Awesome stuff. Well done. All right. Tanduklolo says, how does the moving of the angle affect the structure of the triangle? Tanduklolo, it does not. It doesn't affect the structure of the triangle. It affects what is adjacent and what is opposite. Let me do this. Okay, let's do this. We're going to call this angle over here We're going to call this one theta. And we're going to call this angle here beta, which is also another Greek symbol that we use to substitute for the angle, right? Now, if I have theta over here, in accordance to theta, this is going to be my adjacent side. This side over here is going to be my opposite side. And this side is always going to be my hypotenuse. My longest side is always my hypotenuse. However, if this is my angle over here, if beta is my angle, then my opposite side over here is going to change, because this side over here next to beta is now my adjacent side for beta. And this one over here is now my opposite side for beta, and my hypotenuse will always stay the same. Do you see what's happened? Okay, do you see what's happened, Tanukolo? Depending on where my angle is sitting, my adjacent and my opposite sides will always be different. Afimelia, what's up?
So ma'am, the
Yes.
hypotenuse always stays the same, but what changes is the like angles that are not like opposite to the like hypotenuse. For example, AC and BC.
That's it.
They-
That's it. Good.
Thank you,
You
ma'am.
know, you did that so beautifully. I don't know how else I can put it. My hypotenuse will always be across from my right angle triangle. The things that will change are my adjacent and my opposite sides. Yo, mwah, I couldn't have put it better myself. Okay. Oh, I'm so sorry, Michael. Guys, load shedding is just the worst, isn't it? All right. So we now know that dependent on where my angle is, my adjacent and my opposite are going to switch. Okay, I need to remember this. Okay, so it's going to be a little bit difficult as we go along, but no worries. Now we have to learn 3 new things also. We have to learn about the sine of my angle, the cos of my angle, and the tan of my angle. I'm going to bring back that mnemonic device. Yo, I hate that word. Mnemonic device that we were talking about. And I know Melissa can tell me the answer. I just want to get through my explanation, Melissa, and then you and I can have a chat. Okay. So, ka, toa. All right. So, ka, toa. All right. Now, if I decide, okay, I'm going to remove all of this because I don't want you guys to cheat. You guys must be able to tell me without looking. All right. Tabo says my nickname is Ted. All right. So this actually stands for something very important. Yo, and Uyanda's just like, yes. Okay. This S over here stands for sine. Okay, so sine of theta. Theta or sine of theta is equal to, and whoever's not muted, guys, remember, I need you to mute. Please make sure that you are muted. All right, okay. So the sine of theta is equal to the opposite divided by the hypotenuse. Good. So my sine of theta is opposite over hypotenuse. Okay, that's what the SO stands for. S stands for sine, O stands for opposite, H stands for hypotenuse. Okay, then we need to go to ka. That C stands for cos or cosine, and this A stands for adjacent, and H stands for hypotenuse. Can anybody tell me what is the TOA part going to stand for? I know this stands for tan. What does the O and the A stand for? Melissa, what are the O and the A going to stand for?
O stands for opposite, A stands
Good.
for adjacent.
Ah, beautiful. O, opposite and adjacent. Wow, you did that beautifully. Excellent stuff. Tepiso, don't go away. I see your hand up. I need you to keep your hand up so we can have a conversation. So sine of theta is opposite over hypotenuse. Cos of theta is going to be adjacent over hypotenuse. And tan of theta is going to equal to opposite over adjacent. So the way we read SOHCAHTOA tells us the order in which we need to write these things in. So I can't get there and go, sine is equal to hypotenuse over opposite. No. We need to read it in the order that it's written. Sine is equal to opposite over hypotenuse, never the other way around. Okay, now, Tsepiso, how are you doing? Do you want to unmute for me? Hi.
Hi, ma'am. How are you?
I'm excellent. How are you, my sweetie?
I'm good, thanks. I was having connection problems, but I decided to catch up. Actually, I did not want to ask a question. I actually wanted to answer.
Absolutely.
Sorry,
No,
ma'am.
yes, I want you to answer this question for me. Don't go away.
Okay.
Tsepiso. Now, if this is my angle theta, which
Yes.
side, what is the name of my adjacent side?
Your adjacent side is going to be AC.
Beautiful. This side over here is going to be my side. What is my opposite side to theta?
Your opposite side is going to be BC.
Good, this one. And my hypotenuse.
Your hypotenuse, ma'am, is going to be AB.
Okay, now when I ask you, so I say to you, what is sine of theta is my opposite over my hypotenuse. I want you to write it in terms of my sides. What is my opposite side called again?
Your opposite side is going to be BC.
BC over
AB.
Oh, beautiful. No, don't go
Thank
away.
you, ma'am.
Let's do cos together. Don't go away. What is my
Okay.
adjacent side?
Your
Cos is going to
adjacent, it's going to be AC,
BC over.
AB.
Beautiful. Do 10 for me. Don't go away.
Your 10 is going to be BC over AC.
Oh my gosh. If you were in my class right now, I would just like high five you and give you.
Thank you so much, ma'am.
So beautifully. Excellent stuff.
Thank
Tsepiso. Love it.
you. Thank you, ma'am.
Awesome. All right. Give me a thumbs up. Do we understand what has happened? Thumbs up or thumbs down? Amber says, ma'am, opposite of what exactly? The angle. Remember, Amber, this theta over here stands for an angle. If I decide, Amber, that I'm going to replace theta with 30, okay, I decide what theta is going to be. I can make theta 30 degrees, or I can make theta 45 degrees, or I can make theta 37 degrees. I get to decide what theta is, but theta stands in the place of my angle, much like if I was doing algebra, I could put X in place of a number. Okay, so theta stands in place of an angle the same way X stands in place of a number in algebra. Okay. All right. I'm scrolling through and I'm just seeing thumbs up everywhere, and that warms my heart. It warms my heart. And you guys are just like the best people on the whole planet. I love it. But okay, we must mix, right? I don't want theta anymore. I want beta. I don't want theta anymore. Afimile, are you going to help us out? You're going to help us out, Afimile. Okay, these are all wrong. Hi, Afimile.
Hi, ma'am.
Right. Are you going to help us out here? If this is my angle beta, which side is my adjacent side?
Your adjacent side, isn't it B and C, ma'am?
Good, B, C, excellent. This one here, adjacent. Which is my opposite side?
It's
what is my opposite
it's
side?
A and C.
Excellent, AC. Good, this is my opposite side. And my hypotenuse?
A and B.
Good, A, B. Okay, remember not to say A and B, we just call it AB, okay, because that's the length. Okay.
Sorry, ma'am. Sorry, ma'am.
Okay, so we don't call it A and B, we just call it AB. Okay,
Sorry, ma'am.
is that okay?
Yes,
Mhm.
ma'am. Sorry, ma'am. Also, basically for
That's
sin
not a
and
problem.
cos. So sin and cos, we always have the hypotenuse, but when we have like tan, we only have the opposite side and adjacent only.
Yes, yes.
Thank you, ma'am.
Okay, it's very important that we remember that. Okay. And the way we're going to remember that is if you remember SOHCAHTOA. It's going to help you out a lot. Remember the SOHCAHTOA. Okay. Now, you are still unmuted for me, my sweetie. I want you to answer this next question for me. What is sine of beta?
Ma'am?
Sine of beta. Sine is going to be my opposite over my hypotenuse. What is my opposite side called?
AC.
Good.
AC.
AC over?
AB.
Beautiful. Tell me, what is my cos of beta?
BC
Good.
over AB.
Good, over AB. And my tan of beta?
AC
AC over?
over BC. Over BC.
Beautiful. Lollipop for you too. High fives all around. Beautiful. Excellent. Oh, you guys are amazing. Okay, this is where our lesson ends for today because we're going to continue again on Wednesday. And yes, I saw somebody say, ma'am, aren't we going to use numbers on Wednesday? There's going to be lots and lots and lots and lots of numbers. Okay, lots and lots of numbers. Okay. And then there's also the stuff that we're going to have to look at as well. Okay, we're going to use sides to find angles, but we'll have a conversation about that. Okay, on Wednesday. I don't understand, guys, why are we... Landile says, ma'am, will they give us SOHCAHTOA in the exam? No. So the first thing you do when you get into the exam, you go to the front page in nice big letters and you go, SOHCAHTOA. You write it there yourself so that you don't get lost. Okay. Okay. Akibila's like, I don't want to leave, guys. Mirula's like, I've waited for this ever since the lesson began. I'm so sorry, Mirula. This is the order in which we need to do. We need to do it. I need to make sure that everyone 100% understands where we are at the moment. Okay. Okay. Yeah. You see, Lissetti's like, I know everything about trigonometry. I just need to remember. Absolutely. Ah, thank you. Guys, see, Imanga's like, ma'am, go rest. It feels like you need it. Guys, Imanga understands. I've got the flu. And here you guys are like, no, ma'am, stay, guys. Look, we had so much fun. Okay. And I love how you guys really, really loved this lesson because it means you understood. I'm very happy that we're all on the same page. Okay, if you're not on the same page, I don't want you to leave without being on the same page with me. Okay, so don't leave. Say, Piso, what's up, my sweetie? And answer my poll. Answer Teacher Nels's poll. Hi, Sepiso.
Hi, ma'am, once again. How are you?
I'm good, thank you. How are you, my sweetie?
Good. Ma'am, I wanted to ask in terms of alpha, does it work?
Yes. Because alpha is just going to be another angle. It just stands in the place of another angle. So I can switch out beta for alpha, and then I can just change all of these to alpha. Okay. Remember, for now, Tepiso, we're only going to be working in right-angled triangles. Okay.
Oh, okay. Okay, ma'am. No problem.
Thanks.
Thank you.
You're very welcome, my sweetie. David, thank you so much. Goodbye. I'll see you on Wednesday. Okay. Ketiwe, what's up, my sweetie? Oh, I will. Thank you, David. You too. I'm going to go drink my meds.
Evening, ma'am. Last question. Well, it's not a question, but like in class, we learned a way how to remember SOHCAHTOA. And it's like a funny story. It's like some old hippie, which is for sign or sin or whatever, came
old hippie.
came hopping, which is for cos, and then through our apartment is for tan. So I feel like that's a better way to remember.
the funniest and the best way, because you'll never ever forget that. Some old hippie came
hopping through our apartment.
Came hopping through our apartment. I love it. I'm gonna remember that one.